In another video on conditional arguments, I explore the two most common argumentative forms of modus ponens and modus tollens, or affirming the antecedent and denying the consequent. Here we'll look at some other common argument forms in propositional logic. But first, before we get started, let's consider some assumed principles. These are principles that are assumed to be true whenever we're doing a propositional logic. One is the principle of excluded middle. So what that means is that every sentence is either true or false. There is no in between. Now, vague terms can be problematic, but when we're doing propositional logic, we are assuming that if there are any vague terms, they've been specified. We've stipulated a definition for those so that the sentences are either true or false. And another assumed principle is, of course, a principle that is assumed anytime you are reasoning carefully, and that's the principle of non-contradiction. Now, sometimes this is called the principle of contradiction. I prefer the label I'm using here. And it is the idea that no sentence is both true and false. And the idea is that you have a definite meaning that's understood. You're not equivocating on terms and interpreting the sentence in different ways at different times. You just have the single sentence, one meaning, and it cannot both be true and false. Okay, let's get into some of these common argument forms that we haven't addressed previously. One is a hypothetical syllogism. So this is constructed with conditional claims, like if P, then Q, and a second conditional claim, if Q, then R. And when both of those sentences are true, we can conclude that if P, then R. So this is a valid argument form to provide a standard way of speaking in this argument form. We can see this argument: if it's spring, then the amount of sunlight is increasing. That's our if P, then Q. If the amount of sunlight is increasing, then the potential for sunburn is increasing. And we can put those together and say that it's true that if it is spring, then the potential for sunburn is increasing. That's a hypothetical syllogism. Before we go on to other argument forms, we need to consider disjunctions. So P or Q, we can symbolize this with the wedge here on the right-hand side. And I'm going to explain all the symbols on my video on propositional logic that has to do with connectives and truth values of compound sentences. So if you're not familiar with those, you can look at that video. But for this part, we won't introduce too many other symbols. So logicians treat disjunctions as inclusive disjunctions. So if it merely says P or Q, then we assume that either P is true or Q is true, of course, or this sentence as a whole would be true if they both are true. So sometimes in our normal conversation, we have an implied idea that they can't both be true. But if that's not specified, we assume that it's true in all three of these conditions. So the only sentence as a whole, when that's the only time the sentence as a whole is false, is when both P is false and Q is also false. So when we're doing disjunctions, we are assuming inclusivity. Let's look at constructive dilemmas. These begin with conditional sentences. So if P, then Q, and we have another conditional, if R, then S. We have 4 simple sentences included in the argument. And then we have as the third premise, either P or R. And if these 3 sentences are true, we can conclude that either Q is true or S is true. So here's an example. This is a throwback argument to women's hoops at the turn of the century. If Notre Dame won, then Riley had a great game. And if Purdue won, Douglas had a great game. So we have our P, Q, and R and S. And either Purdue won or Notre Dame won. And from that, we can conclude either Riley had a great game or Douglas had a great game. This is a constructive dilemma. Let's look at a destructive dilemma. Somewhat similar in the start in that we have two conditional sentences, if P then Q, if R then S, only this time our third premise is not Q or not S. So here's an example of an argument. Well, we have the conclusion, of course, not P or not R. When we put those three premises together, we can conclude that negative disjunction, not P or not R. Here's an example from the 2020-2021 time frame. If Bryant has a career year, then the Cubs win the pennant. If Goldschmidt has a career year, then the Cardinals win the pennant. Either the Cubs do not win the pennant, or the Cardinals do not win the pennant. So either Bryant does not have a career year, or Goldschmidt does not have a career year. So we are basically doing a modus tollens times 2 here to get to our conclusion. Sometimes there are happy dilemmas. So here's an example. If I eat at McDonald's, then I won't have to pay much for supper. If I go out to Vitale's, then I will have a fine meal. And I'm going to do one of those two things. I'll eat at McDonald's or go out to Vitale's. And from that, we can conclude that I won't have to pay much for supper, or I will have a fine meal. And this is just showing that not all dilemmas are bad. Often when we use the term dilemma in everyday conversation, we imply that this is a bad situation. But of course, in logic, that doesn't have to be the case. All we're doing is drawing out the consequences. There are false dilemmas sometimes. So when there are more than two options that are available, but the disjunction doesn't address all of those alternatives, we're going to have a structure that's valid here, but the disjunction, in this case, premise 3, is false. So we have the form of a constructive dilemma. If I take logic, then I'll have to work hard. And if I take underwater basket weaving, then I will not learn anything useful. And I have to take logic or underwater basket weaving. And so we could conclude from that, I'll have to work hard, or I will not learn anything useful. Now, we have to keep in mind, right, the structure here is perfectly fine. So this is a constructive dilemma. This is a valid deductive argument. But a false dilemma is when the disjunction, in this case, again, premise 3, is false. It would be quite rare for somebody to be forced into that situation where you have to take one of those two courses. Let's consider disjunctive syllogisms. So let's just look at the case first, and then we'll consider the form. Either Ahiam will apologize or Zelek will not converse anymore. Ahiam will not apologize, therefore Zelek will not converse anymore. So here the form is fairly simple. We have the disjunction, either P or Q, and then we rule out one of those disjunctions, in this case, not P, and from that we conclude the other disjunction is true, therefore Q. So this is a valid argument structure, and this is a very common way of reasoning with a disjunction, this form of disjunctive syllogism, where you have the disjunction, negate one of the disjuncts, and you conclude the other one is true. Now, I do want to consider briefly an invalid form that sometimes people slip into mistakenly, and that's when you have a disjunction and then you affirm that one of the disjuncts is true, from that, it would be a mistake to conclude that the other disjunct is false. Again, that's because we're using inclusive disjunctions when we are doing propositional logic. So an example of this might be when Jerpel will do the homework or he will fail. Jerpel will do the homework, and from that we conclude Jerpel will not fail. Of course, the problem here is both the first and second premise could be true, but Jerpel neglects to take any of the quizzes or exams, and thus Jerpel does fail, showing that we could have true premises and a false conclusion, which means we have an invalid argument form. One more argument to consider in this video, and that is one of an exclusive disjunction. So sometimes you might want to communicate the fact that you can have one thing or another, but not both. So a waiter might want to communicate this. You can have soup or salad, but not both, right? The implication there is an exclusive disjunction is being considered. So this would be P or Q, but not both P and Q. And we can symbolize this in this way. We have the first disjunct, P or Q, and it's not the case that P and Q. So we're ruling out the conjunction being true. And so when you say, well, P is true, now you can conclude that not Q is true. So I will eat pizza or hamburgers for supper, but not both. And then if you say I'm eating pizza for supper, you can conclude the negation of that other disjunct. I am not eating hamburgers for supper. This is a valid structure, so don't get it confused with the invalid form that we just considered.